To find a vaccine, one has to turn the pages of history hundreds of years ago. There is a rumor that Buddhist monks did not bite snakes, because they used to drink snake venom. In this way, they were able to resist snake bites. Although there is a debate about its truth or falsity, a method called inoculation was practiced in China about 600 to 700 years ago, which can be called the prototype of the modern vaccine. By the time of the Ming Dynasty, however, smallpox was striking fairly regularly. This process is adopted to avoid this. From the pus of a smallpox patient, the disease material was injected into the body of healthy people, and it was found that most of them remained perfectly well even during the smallpox epidemic. The diseased skin parts were first dried, then finely ground into powder. This powder had to be inhaled through the nose. In China, it was customary to inhale powder through the left nose for girls and the right nose for boys. This method reached the Ottoman court from China. Europe was weak in the spring. News of inoculation spread from the Ottoman court to England, and despite opposition, inoculation gradually became popular and was used by the royal family. But the use of direct pathogens is risky, and applied to large populations is not easy. As a result, the search for new methods was going on. Renowned physician Edward Jenner came forward. On May 14, 1897, an 8-year-old boy named James Phipps was infected with the smallpox virus, which was a weaker disease than smallpox. Many in England at the time knew that those who had cowpox or cowpox were not infected with smallpox. But Jenner was the first to bring the whole thing into a scientific way. Phipps felt a little sick for the first week, but soon recovered. Later, the smallpox virus was applied to him and it was found that the disease was killing people in Qatar and nothing was happening to Phipps. An investigation into the causes and effects of the variolae vaccinii, a disease discovered in some of the western counties of England, particularly Gloucestershire, and known by the name of the cowpox. He named his method vaccination from the Latin name of the cow, vacca, since he has used the germ of the cow. The name of this medicine is vaccine. Back then it was only known for smallpox. This led to the recognition of the father of vaccination after Jenner. The then Royal Society was not interested in this new method due to the paucity of Jenner data. However, on a personal level, many physicians continue to benefit from the use of Jenner's vaccination. By 1801, nearly 1 million people had received the vaccine. Vaccination became the main defense against smallpox, gradually removing inoculation from the scene. But the limitations of Jenner's process also quickly became apparent to scientists. While researching the preparation of a vaccine against another disease in the same way, he found that cowpox does not occur in all diseases like smallpox. Moreover, many animal-borne diseases can be fatal to humans. So they focused on inactivating disease-causing microbes. Then it might be possible to safely introduce them into the human body. This will kill 2 birds with 1 stone, reduce the risk of disease, and also build immunity. So scientists conducted intensive research. They realized that there were 2 options open to them: 1, kill the germ and introduce it into the healthy body, and 2, keep the germ alive, but weaken it by various processes so that its ability to cause disease in the human body is reduced. In both cases, they were expecting the same result. Scientists from different countries were continuing research on this until about 150 years after Jenner's discovery. French entomologist Louis Pasteur achieved a remarkable breakthrough. He found that by exposing anthrax and rabies germs to oxygen and heat, their lethality was reduced. Using this weak bacterium, he developed the anthrax vaccine in 1881 and the rabies vaccine in 1885. The Pasteur Institute he founded in 1887 continued to work on vaccines after Pasteur's death. In today's world, this French institute is one of the non-profit organizations working on vaccines. At the beginning of the 20th century, another revolution was achieved in vaccines. French Dr. Albert Calmette and veterinarian Camille Guérin developed a vaccine for tuberculosis, one of the most dangerous diseases of the time, following the path shown by Jenner and Pasteur. For this reason, they repeatedly propagated the bacteria that caused tuberculosis in cows in an artificial environment. After 230 generations, a species was found which, although a species of the bacteria that causes tuberculosis, is relatively less virulent. It was with this that they made their vaccine, which is still known today as BCG, Bacillus-Calmette-Guerin, after their name. Pasteur's method quickly became popular. Vaccines have been developed for measles and mumps. But the problem did not end here. Scientists have found that even the weakest virus bacteria can cause disease for a variety of reasons. Today we know that mutations often give rise to more serious diseases. That's why many people thought it was safer to use dead germs. The vaccine was first developed by two researchers, Salmon Smith and the Pasteur Institute, about the same time as the first dead germ. This method is first applied to the germs of typhoid, cholera, and plague. In England, two scientists named Wright and Sample were the first to administer the typhoid vaccine. Hufkin was the first to use the plague vaccine on humans. Another scientist by the name of Cole developed the deadly cholera virus as a vaccine. Earlier, Hufkin had vaccinated cholera with live bacteria separately, but in the end, the cholera vaccine survived. In the 19th and 20th centuries, vaccines against diseases such as cholera, tetanus, and influenza were carried out by dead germs. Thus a vaccine for plague was developed in the late 19th century. Let's first use high heat to kill germs. However, in 1925, Alexander Glennie R. Hopkins, a well-known British immunologist, inactivated tetanus toxins with formaldehyde. Later, the process of killing germs with a mixture of formaldehyde or formalin became popular. The diphtheria vaccine was developed in 1928 using this method. It took another 22 years for the tetanus vaccine to hit the market. Calmette and Guerin developed a vaccine by growing bacteria in an artificial environment. It took about 35 years, 1950 to 85, for such an artificial environment for viruses to be discovered. Based on this, in 1955, American virologist Jonas Salk prepared the polio vaccine, which contained the dead virus. He chose formaldehyde to kill the polio virus. Salk's vaccine had to be given to the body by injection. It had the advantage there is no possibility of polio being dead. 7 years after Salk, American-Polish researcher Albert Sabin developed an oral polio vaccine using a weakened polio virus. His polio vaccine was widely accepted because it could be administered orally and required no special training for the operator. However, there was a very small risk of contracting polio, which later proved to be almost nil. Since the 1940s, scientists have been experimenting with different parts of the body. They had in mind how to make a vaccine with a small portion without using whole germs. The hepatitis B vaccine came along the way. At the same time, scientists were working on how to make vaccines by inactivating viruses as well as bacteria, because until then, vaccines made from dead germs were all against bacterial diseases. The first vaccine thus developed was influenza, followed by the hepatitis V vaccine. Vaccines are currently being developed using DNA, RNA, vector viruses, etc., which we see in the case of coronaviruses. That's all for today. If you enjoy our video, then please like the video and subscribe the channel and press the bell icon for further updates. Thank you.